So just over 2 weeks ago, we had the December solstice. And can the flat Earth explain this phenomena? Now, I think that everybody agrees on the definition of a solstice. Here would be the example on a flat Earth. So in the June solstice, the sun would be orbiting over the Tropic of Cancer, and in the December solstice, over the Tropic of Capricorn. And of course, on the globe model, this is caused by axial tilt. On the December solstice, the North Pole is tilted away from the sun, so the noon sun would be directly overhead for people on the Tropic of Capricorn. And of course, in June, the opposite would be true. It would be directly overhead on the Tropic of Cancer. So let's start by having a quick review of how the sun moves in the northern hemisphere during the June solstice or summertime. This is from suncalc.org, and what is nice about this web page is that it shows the path of the sun during the day. This is for Seattle, which is at 47.6 degrees north, and this is where I was born and raised and lived most of my life. So here are the four cardinal points, north, south, east, and west. And it is quite easy to see in Seattle that yes, the sun does rise towards the northeast and set towards the northwest. And of course, since this is summertime, we have our longer days. On this day, it is 6 hours and 6 minutes long. Now, this is a video showing a sunrise in Seattle. And in the northern hemisphere, you will see the sun move from your left to your right all day long. So that video matches what you see in this graphic as you watch the sun during the course of the day. Of course, sunrise is at 53 degrees up towards the northeast, and then you would turn right to see the sun at noon in the southern sky. Turn right again to see sunset at about 307 degrees. And at nighttime, that sun would continue moving to the right, and it would appear to be going around the North Pole to rise again the next morning in the northeast. Now, if you believe in a flat Earth and don't really pay much attention to the exact direction of sunrise and sunset, this seems to work on a flat Earth. Here we have the equator in the Tropic of Cancer, and of course you can see that the sun moves to the south of Seattle. So if we put that graphic from suncalc.org on here, the sun does appear to orbit around the North Pole. So this is the observed sun on the December solstice from Seattle. Now the sun is rising in the southeast and setting in the southwest. And since it is winter time, we are having our shorter days. On this day, it is 8 hours and 26 minutes long. And again, like I say, if you don't pay close attention to sunrise and sunset, this seems to work on a flat Earth. Here we have the equator in the Tropic of Capricorn. So again, all of this seems to work. But there is a problem here, because remember, we have 8.5-hour days during winter. And if that's the case, this is where the sun would actually have to rise and set. And you can see that it is almost due east and due west of Seattle. So the model is already falling apart. So let's see how the December solstice works on the flat Earth model for New Zealand. Here we have Christchurch on the two islands of New Zealand. Over here is Australia. And you can see that New Zealand is to the south of the Tropic of Capricorn. So if the Earth is flat, the sun should always be to the north of New Zealand. So this is sunrise and sunset for the June solstice, which is winter in Christchurch. And this does seem to work on the flat Earth. But here is the December solstice, and now we have a big problem because the sun is rising towards the southeast and setting towards the southwest. And of course, since it's summer, they are now having their longer days at 15 hours and 26 minutes. So here the sun moves in the complete opposite direction of what we see in the northern hemisphere. It is moving from your right to your left. So you turn to the left to follow the sun during the day. So when we apply this to the sun count graphic, it's the complete opposite of what we see in the northern hemisphere. So here we're looking to the southeast to see the sunrise at 124 degrees. And of course now we are turning to our left to follow the sun to the northern sky at noon. We continue turning left to see the sunset in the southwest at 238 degrees. And of course at night that sun would continue left, but this time across the southern horizon or around the South Pole to get back to the southeast to rise again in the morning. Why would we see a sun orbit that was around the South Pole on a flat Earth? Now the flat Earth argument is that, well, this is what we should see because we're observing this from the opposite side. And this is true. This is part of the explanation of what we see. But of course the flat earthers are ignoring the elephant in the room. But in the southern hemisphere, the sun would have to be rising way up here in the northeast and setting way over here in the northwest to get those long summer days. I mean, if you have a model where the sun orbits around the North Pole, then everybody on Earth should see this. But they don't see this in the southern hemisphere. They see a sun that orbits in the complete opposite direction around the South Pole. So here's the graphics comparing the summer sun for both Seattle and Christchurch. And you can clearly see that these sun orbits are completely opposite of each other. Now I'm going to play a video from D. Marble. He went up to Alaska and recorded the midnight sun. And we're going to see that sun moving from the northwest to the right to the northeast. So there we go. It is moving from your left to your right or from the northwest to the northeast. So now I'm going to play a video for the southern hemisphere. This was taken from Auckland, New Zealand, and this is an incredible video. I'm going to leave a link in my description. You should take a look. This guy used an equatorial mount, and he followed the sun from sunset in the southwest to sunrise in the southeast. So let's take a look. So here's the setting sun, and again he's using an equatorial mount to track the sun as it moves from right to left to the eastern sky. And now you can see the stars come in. This is the clockwise rotation around the south celestial pole. Here comes the Milky Way. Unbelievable video. And pretty soon we will see the sun rising. So both of those videos validate exactly what is shown on these graphics. And of course, everyone seeing the sunset in the same direction is easily explained on the globe model. Here we have the December solstice. We have the Earth axis at an angle with the North Pole facing away from the sun and the South Pole tilted towards the sun. And the terminator line would be going straight up and down. So of course, everybody on that terminator line from the northern to the southern hemisphere would see the sun rising from the southeast. And of course, the opposite is true in the June solstice. This is when the North Pole is tilted towards the sun. And again, on the terminator line, now everybody sees the sun rising to the northeast. So I think the honest answer is that the December solstice sun destroys the flat Earth. And getting back to that day length issue, I put this video out a couple months ago. This is for two different cities on the same longitude on the December solstice. So to the left, we have New York over here. And for the shorter 9-hour day, this is where sunrise and sunset would be. And directly south of New York in South America is Punta Arenas, Chile. And for their much longer day, this is where sunrise and sunset would have to be. Now, if you look at this and can't figure out the problem, then you're really not thinking at all. So it's time to wake up and smell the coffee because we live on a globe.